the video again in class, or that might equally be nice. So let's begin. I hope that all of you watching have subscribed to this channel. Have you done that?
Yes, sir.
All right. So I have not. All right. So the first question reads, the absolute value of x plus 1 is strictly less than 2. Then x should lie in the interval. So how do we split this equation?
So I think you square the both sides.
Right, you can square the both sides. That will also be another way. And if you forget everything, you use that procedure, it will be good. So here we can divide it as follows. X plus 1 is less than 2, or x plus 1 is greater than negative 2. So if we break this down, we're going to have x is less than 1 or x is greater than negative 3. Now let us square it and we see what we are going to obtain. So if you square both sides, we are going to have x squared plus 2x plus 1 to be strictly less than what? 4, right?
Yes, sir.
And a quadratic inequality will now be x squared plus 2x minus which number? Minus 3 less than 0. Yeah. And if we factor that out, what are we going to have?
You have 1 and negative 3.
Right, x minus 1 into x plus 3.
Plus 3, yeah.
And this should be less than 0. And we can now test this point because the boundary solutions are 1 and negative 3. Okay, negative 3 and 1. These boundaries are not included. We can now test these boundaries. So to test this, we can take a number that lies between negative 3 and 1. So that we just test using this one. This solution. If this area is not satisfiable, then we just choose the other sides. All right, let's take 0 and test here. 0 minus 1 is negative. 0 plus 3 is positive. Positive times negative is negative. So positive. This region
negative.
Is the negative number less than 0?
Yes.
Yes, sir.
So this region satisfies. And these results match with what we already have above here, because x is less than 1 and x is greater than negative 3 can be written like this. X is less than 1 and x is greater than negative 3. So the same solution. So what is the key here? C. Right, so our key here is C. Let me clear all of this. So this is how we can write it. And I've drawn the number line. All right, question 2. Given that x is greater than 0, the value of x for which log x base 4 plus log 6x plus 10 base 4 equals 1 is. So what do we apply here? As the revision keeps on going on, the students will be speaking more than the teacher, as we already know. We just have to apply the law of logarithms here, okay?
Yes, sir.
The bases are the same, 4, 4. So this will give us log A plus log B is equal to log AB. That's log A times log B. So here we are going to have x times 6x plus 10. So x into 6x plus 10 is equal to 1. And we can now convert from logarithmic form to exponential form. In that case, we will have 4 to the power 1, this 4 here, which is the base, to this power to be equal to all of this quantity here. So this will give us 6x squared plus 10x to be equal to 4 to the power 1. The 4 to the power 1 is 4. So we end up with this quadratic. And from this quadratic, we can factor out 2 and cancel out, or we may just solve. From here, our discriminant will be b squared minus 4ac. So we have 10 squared minus 4 times a, which is 6, times c, which is minus 4. And that gives us 196. That's the discriminant. So from here, x will be negative b plus or minus root 196 on 2a. And this is the value that gives us 4 on 12, which is equal to 1 on 3. Which is equal to 1 on 3. This one is clear, right?
Yes, sir.
All right, that's nice. Okay, the next question is, what question number? I cannot see the question numbers.
Question number 3.
All right, question number 3. Now, if f of x equals x cubed minus 2x minus 1, then f of negative 2 equals, oh, this one is from 2 work now. Everybody
Yes.
has this one. So this should be equal to negative 2 to the power 3 minus 2 into negative 2 minus 1. So that gives us minus 8 plus 4 minus 1, which equals minus 5. Of course, I'm sure everybody had this one.
Yes, sir.
Good. Please, it's good that at the end of this class, you should solve this paper again, because the teacher is the one solving now, not you. So at the end of the day, I'm the one who has the skills, not you. You have the knowledge, but you don't have the skills. So the advice, you solve the paper again. Because some of these questions you still do in the GCE. Like I realized that most of the questions of 2019 were there in 2021. So you can never tell if most of the questions of 2020 will be there in 2022.
God forbid.
All right, the next question is question 4. The tangent, the acute angle between the lines y equals this and y equals that is. How do we get the tangent of the acute angle between two lines?
We look for their gradient.
Okay, what's the gradient of the first line?
4,
And the second line?
1.
So how do we find the tangent of the acute angle using those two gradients?
We take the gradient of the first line and multiply with the gradient of the second line and divide all through by the gradient of the first line plus the gradient of the second line.
Excellent. Thank you for solving it. Let me just put what you have written here because there's no need to solve again. That's what you meant, right?
Yes, sir.
Any comments from the other participants? Gwen, do you have anything to say? Gwen, are you there?
Yes, sir. I'm there.
I just hope you're not watching Legend of the Seeker because I saw you there.
Nah, I'm not.
All right. So this gives us
It's just that my internet is doesn't have it.
okay. So this gives us M1, M2 on M1 plus M2. And the tangent of that angle is equal to 4 on 5. Do we have the answer anywhere here?
No, we don't have the answer.
All right, so it's not there. And since this is multiple choice and they will not penalize you for choosing the wrong answer, just look for one and take. So if I was the one,
Anyone?
I think I would like to choose D.
I'll take D.
Yeah, because it's close. It's close to this one. Yeah. Of course. All right, that's nice. Okay, question 5. The period of the function f of x equals cos 5x is? How do you get the period of a function? Now, let me show you a shortcut. What is the period of the cosine function? If you have y is equal to cos x, what's the period of the function?
Omega t.
2 pi, right? I'm sure that's one to say.
Yes,
Or
2 pi.
yeah, or 360 degrees. Yeah, 2 pi n. So it repeats at intervals of 360 degrees. If you put n, it means intervals of. If I replace this one here by anything, for example, 5x, I'm going to take that 5x that I have here and equate to this 360 degrees and solve for x. That gives me the period. But note that they've given this question in pi, but I'm just working in degrees so that I show you exactly what to do. So what's 360 degrees divided by 5? 72 degrees, right? Good. So whenever you have a function, you have a periodic function, y equals a, whether sine or cos, because the sine and cosine function have the same period of 360 degrees. So let me say sine bx plus c. This is what you do to get the period of the function. C has nothing to do with the plus this constant plus C has nothing to do with the period. A equally has nothing to do with the period, but it has something to do with the amplitude. So the only thing that determines the period is this one. So from here, you have bx to be equal to the period, that is 2 pi. Is equal to 2 pi. And from there, you can solve for x. So the period of such functions will be x is equal to 2 pi on b. So from this question that we have here, what is the period of this function?
2 pi on 5.
Good. So we can start. The answer is already here looking at you and smiling. Is this okay for all of us?
Yes, madam.
Madam, is my voice already coming out like Madam's voice? Madam is not the one today, I'm the one. I told these people about this microphone that they gave me. Like, is that this microphone is changing somebody's voice to a woman's voice? They thought I'm joking. Please, let me switch back to my microphone because this one like this is making people to call me Madam now. I may greet somebody on the way, they'll think that is Madam. All right, please, just a minute. Let me move back to my microphone. Hi. Wait, it's not bad. You can show my ID card on the still no, you are Madam. Or I come to your school now, you said no, the person that was talking online was Madam. I have no evidence. All right, please, just a second. Let me switch to my microphone. Not Madam's microphone anymore. Let me see if it connects. Oh my God. This sheet now. This sheet. Okay, connects again. Oh my God. Welcome to those who are just joining us online. Hello, you're welcome to the class. All right, statistics class is on Tuesday. Look, the microphone is refusing to connect. I think I'll just continue this one. I don't have any choice. Okay. So from here, the period of this function is 2 pi on 5. So let's see how this is done. So whenever you have a function of the form a plus bx plus c, then the period of the function is given by, look at it, the absolute value. So we have 2 pi on the absolute value of b here. So in this case, we have 2 pi on 5, which is the period that we have here. Okay. Okay, the next question. Expressing this in partial fractions. We have no problem with this, right? Is there anybody who has a problem with this one? Anyone who has a problem with this? Anyone? Okay, nobody has a problem. So to express this in partial fractions, can somebody tell us what to do?
Sir, you say, can I say something?
Yes, go ahead. You are the
Okay.
because I'm just
Okay,
like
you just say, you say A
yes.
on x minus 3 plus
Yes.
B
on x minus 5.
Okay,
And then you look for the LCM.
perfect. Perfect. Thank you so much. This is good. So this should be identical to a on x minus 3 plus b on x minus 5, as you have mentioned. So we can multiply all through by this LCM, which is x minus 3 into x plus 5. And this is the result we'll be left with. So from here, we can either equate coefficients or we do the cover-up method. Anyone we use will have the same result. So I want to equate coefficients. So I'm equating the x for the x. On the left-hand side, the coefficient of x is 2. On the right-hand side, the coefficient of x are, you have ax plus bx. So I have a plus b, all of that times x. So a plus b is equal to 2. And if I'm taking the constant, I have minus 5a minus 3b equals 0. Solving for these two will give me the following result. B equals 5 and a equals minus 3. In partial fractions, this becomes my a is equal to minus 3. So this is the key, and yb is 5. This one is clear for everybody, right?
Yes, sir.
Okay, thank you so much. Let's move on to the next question. Oh, I like this one because I know many people will not like this one. Now, the function f of x equals x cubed plus 1 is continuous in the interval from -2 to 4. That's continuity and differentiable on the interval -2 to 4. This is differentiability. So this question is on continuity and differentiability. Now the value of the constant c, where c lies in the interval from 2 to 4, for which f prime of c equals f of 4 minus f of minus 2, all that on 4 minus 2 is, anyway, they have given the equation directly. It's good. Can you get me?
Yes, sir.
Okay.
Yes, sir.
So we just need to look for f prime, right?
Yes, sir.
From this question, what is f
Yes,
prime?
sir.
Prime is going to be 3x squared.
All right, 3x squared. And what will be f prime of c?
F prime of c is going to be 3c squared.
Thank you so much. So we just equate that 3c squared to what we have now on the right-hand side, right?
Yes, sir.
Good. So we have this. So I would first of all like to start by looking for f of 4. For this question, f of 4 is 65. That is 6 to the 4 to the power 3, which is 64 plus 165. And then f of minus 2 is minus 2 to the power 3 plus 1, which is minus 7. Then I now look for my f prime of c. F prime of c will be 3c squared. We first of all differentiate f of x. And then we now replace x by c. So we can now equate all of this. Since we already have all the parameters, we put this into the equation. We'll have our f prime of c, which is 3c squared, should be equal to f of 4, which is 65, minus f of minus 2, so minus 7, all that on 4 minus 2 is 6. So from here, we will have c squared, when we simplify, is equal to 72 on 18. So our c squared is equal to 4, and c equals, what is a sweet question? I'm sure everybody is very happy with this question. And nobody.
So I'm not.
Why are you not? Tell me, where are you not happy with this question so you can make you happy?
I don't understand the question. It's a bit tricky.
Okay. Now, it's this question, I'm happy with this question because they made it direct. Because if you look at what we have here, f prime of c equals this, they'll give you everything. If I'm the one setting, I'll not tell you these things. So this is what we'll do. Just look at this last part that I said first. We start by looking for f of 4. So that will replace it here. Our f of 4 is 65 as we have here. Now let's look at f of 2. F of 2 is equal to -7. Now we have been told that f prime of c, so we need f prime first. F prime, as we saw, f prime as the other students just gave, f prime of x is equal to 3x squared. Is equal to x squared. So from here now, what will be f prime of c? F prime of c will be 3c squared, which is what we have here. Now that we have everything, we just have to substitute those values inside this equation which I've circled now. F prime of c is 3c squared. This is it here. F of 4 is 65.
Yeah.
This here. F of minus 2 is minus 7. And 4 minus minus 2 is 6. And when we simplify this,
So excuse me, how did you get f of 2?
f of 2
Yeah.
is f of minus 2, right?
Yes, sir. F of minus 2. How did you get it?
F of minus 2, you just put inside this function here.
So okay. Okay.
Yeah. So you have
Thank
minus
you.
8 plus 1 minus 7. Now, let me tell you another way that they can set this question, which is the way that if I'm the one, I'll set it. I will say you should find the constant c such that f of x is differentiable on this interval and continuous on this interval. And I'll not give this last function. Say, yes, find the constant c such that this function is continuous on this interval from minus 2 to 4 and differentiable on this interval from minus 2 to 4. Whenever they say that, you have to apply this equation that is circled like this on the left-hand side. You see f prime of that thing you are looking for is equal to f of 4 minus f of 2, all that on 4 minus minus 2. Or you say f of b minus f of a, all that on b minus a, that's the formula. So they gave it directly, so that there's no straight. Oh, these people are very good people. May God bless them.
Hey.
I know, right?
Yeah, of course. If I'm the one, people will come out, they'll not be seeing places very well again. Okay. But I'll not give that in an exam. Can give that during a preparation so that people should prepare very hard and go and meet things which are easier.
Yes, sir.
Yeah. An arithmetic progression has first term link 2 and common difference link 4. The sum of the first 4 terms of this progression is, the first term is link 2 and common difference is link 4. The sum of the first n terms is given by n on 2 into 2a plus n minus 1z. So the sum of the first 4 terms will be an AP. 4 on 2 right.
Yes,
Do you
sir.
this formula? Let me remove my formula. What's the sum of the first n terms of an AP?
Sum of
The first n terms of an AP is given by n over 2 into first term plus which term? Last term now.
yes, sir.
This is one of the formula. Another one, if you don't know the last term, you can use n over 2 into, use the formula for the last term. Formula for the last term, this is a. So the last term is a plus n minus 1 times d. This is the last term. And because now I have 2 a's, this is the first term. The first term is a plus the last term, which is a plus n minus 1z. That is why in that formula, we have 2 a's here. So n over 2 into 2a plus n minus 1z. So let me show the formula here. So this is the one that you will know very well. So for the first 4 terms, we'll have 4 over 2. Our first term is ln 2. So 2 times ln 2 plus 4 minus 1 times common differentiation is ln 4. So we'll have 2 into 2 ln 2 plus 3 ln 4. But ln 4 is the same as 2 ln 2. So this one will become 3 times 2 ln 2. Ln 4 is equal to ln 2 to the power 2, which is 2 ln 2. This is it here. So I'm going to replace ln 4 with 2 ln 2. And this one will now give us 3 times 2 ln 2, which is 6 ln 2. So ln 2 is now common. 2 ln 2 plus 6 ln 2 is 8 ln 2 times 2, 16 ln 2. And of course, the key is there, smiling. This one is a good one, right?
No,
Yes, sir.
It's a very bad one.
It is.
Okay. That brings us the next question. If x squared plus y squared equals 16x, then divide the x equals. This is implicit differentiation.
Yeah.
If the class end in the next 9 minutes, please, you join again, okay?
All
Okay,
right,
sir.
Yes. Now we have x and y as variables here. So we are going to do implicit differentiation. When I started teaching this class, because our classes begin in August, those who started attending these our classes since August, we have taught all of these things. Are you surprised?
Yes.
Yes, because we always intend
What's
that
there?
we always try as much as possible that we finish pure math mechanics by latest December or January. And then we now fall on mechanics and statistics from that period, maybe to latest April. And then we continue with revision in May. So we have really covered so much. We are telling you this story now. It's really a story. Good. Now, so here we have 2x. And the thing is that after we have taught all those lessons, we remove all the notes online. Very bad people. So let's differentiate implicitly with respect to x. We differentiate x squared with respect to x, we're going to have 2x. When we differentiate y squared with respect to x, what are we going to have? When we differentiate 2y with respect to x, what are you going to have? 2y divides the x, okay?
2
2y
Yes, sir.
divides x. Because you are differentiating y with respect to x. Please, is this clear?
Yes, sir. Yes, sir. It's clear.
Yeah, because this one like this is 2x dx on dx. But since we have dx on dx, it cancels out. That's why the dx is not here. This one is dy dx. This one does not cancel out. All right, so that should be equal to, we differentiate 16x with respect to x. That's going to give us 16. From here, we are going to make dy dx the subject. So this will be equal to, so 2y dy dx should be equal to 16 minus 2x. We divide both sides by 2y. So dy dx will be equal to 16 minus x on 2y. That gives us, I have to mute this. Somebody's having noise in his or her background. Okay. So you see that 2 is common, right? So we can factor it out,
Yeah.
the numerator and denominator, and then we cancel out, and we are going to have 8 minus x on y. So this is the result. The key is there. The key is B. The year was really a sweet year. Okay, question 10. The radius of the circle with equation x squared plus y squared minus 10x plus 12y plus 41 equals 0 is. So the radius of this circle, how do you find the radius of the circle?
By taking the square root of g and f
Minus.
minus c.
Wow, that's nice. So from this general form, g or 2gx will be equal to negative 10. So g is negative 5, right?
Yes, sir.
So g is negative 5. And our 2fy is equal to 12y. So from there, f will be equal to 6. And from here, we don't even need to look for negative g, negative f. We just need to look for c. Our c here is equal to 41. Therefore, our radius should be equal to g squared plus f squared minus c, as we have said. And this gives us root 20. In third form, simplifying it will give us root 4 root 5, which is 2 root 5. So this is 2 root 5. I hope this is clear.
Sorry, there's
Yes,
another
sir.
way of doing this without using this formula, right?
Yes, there's another way
Like
of doing it without using the formula.
For
Yeah.
the thing and the okay.
You want to
because
convert,
I know the other way.
okay, you want to convert it
The
to Cartesian
formula
form?
is the other way.
Would you like to convert to Cartesian
Yeah.
form first?
Yes.
Oh, okay. Let us do Cartesian form method.
Yes, sir.
So here, let me just clean these ones back and then
Okay.
we do Cartesian. Oh, somebody's at the door. Okay, somebody's in the parlor. So using the Cartesian form, you have x squared minus 10x
10x.
minus 10x, so plus 25. Yes, please, come in. So minus 25, I'm sorry, plus 25. I'll subtract the 25 because it's not supposed to be there. I'm converting it to a perfect square. Now,
Yes, sir.
plus, for the y's, I have y squared plus 12y's,
Mhm.
12y, plus what?
Plus 144. 144.
The one, is this 144?
Yes.
Is it 36?
Wait.
Yeah, plus 36, right?
It's 6. Yeah, 6 and 6. Yeah.
Okay, the pen is written to right. Plus 36, and then we subtract the 36 back, minus 36. So plus the 41 that was there. 41 is equal to 0. So this now becomes x squared minus 10x plus 25 is x minus 5 squared. X minus 5 squared. Then y squared plus 12y plus 36. This gives us y plus what? Y plus 6 squared. And this should be equal to, I'm carrying all those constants to the right-hand side. On the right-hand side, we'll have 25 plus 34. So that gives us 59.
It's 36.
59 minus 41. Okay, 36.
That's
Okay, yes, this place is supposed to be 36. Thank you. Yeah, I wrote 34 instead. All right, so we have minus 25 minus 36. It's minus 61 now. Minus 61 plus 41, minus 20. So it is the right-hand side, it becomes 20. So by this 20 is equal to r squared now. Right?
Yes, ma'am.
So from here, our r is equal to the square root of 20, which is equal to that 2 root 5 that we have. Okay, so this is Cartesian form method. Well, this is nice. Can I clean the board? Can we move to the next page? Or we hold on a bit?
Sir,
Yes, I can clean
Yes.
up.
please ask a question.
Please ask.
How life coming about?
Which particular step?
The first was
The first step.
yes, sir.
What I'm doing is I have to, I'm converting this to a perfect square. I already have x squared minus 10x. So which number should I add here to make this thing a perfect square? What the number I should add should be a half of this term, a half of minus 10, square it. Just like when you're doing completing the square in quadratics. So you take a half of this middle term, which is minus 5, you square it. And when you square it, you're going to have a 25. But there was no 25, so I will put the 25 and subtract it back outside. Now, this one is a perfect square, which can be written as x minus 5 all squared. The same thing too with the y. I have y squared minus 12y. So I'll take a half of 12, which is 6, square it, add it here, and subtract it again. So now this one is a perfect square, you can be written as y plus 6 all squared. And then we now just simplify. Okay,
Yes, sir. Thank you.
you are welcome. All right, welcome to the person that is just joining us, Severin and VB. Can I get VB's voice?
Yes.